Welcome to Mathematical Technical Workshop in Similarity and Congruence, Episode 2. In geometry, similar figures are alike in a very specific way. They may have different shapes and sizes, or they have same different sizes, and vice versa. In similarity, two polygons have to have corresponding sides which are proportional and the corresponding angles which are equal. Example, are triangles ABC and DEF below similar? Now in the above triangles, we can see that angle A is equal to angle D, and they are both equal to 53 degrees. Angle B is equal to angle E, which are both 37 degrees, and angle C is equal to angle F, which are both right angles. Similarly, if we look at ratio of side AB and DE, AB over DE is equal to 5/10, both in centimeters, which gives a ratio of a half. Ratio of BC and EF is equivalent to 4 centimeters divided by 8 centimeters, which is equal to a half. And also, the ratio of CA to FD is equal to 3 centimeters divided by 6 centimeters, which also gives a half. Now from these two arguments, A and B above, we may say that triangles ABC and DEF are similar from the fact that the corresponding angles were equal and the corresponding sides were proportional. And the triangle ABC is similar to triangle DEF, which is written as triangle ABC similar to triangle DEF. This symbol here represents is similar to. Now in triangles, it is enough to show that they are similar by using the following theorems or postulates. One, you can have pairs of corresponding sides which are proportional, and that theorem is called side, 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 written shortly as SSS. Otherwise, you can have pairs of corresponding angles which are congruent or equal, meaning the theorem angle-angle or angle-angle-angle theorem. Otherwise, two pairs of corresponding sides are proportional and a pair of included angles are equal, which is called side, angle, side similarity theorem. Now, we can perform an activity to show how these theorems can be used to prove some theorems of similarity in different triangles. Activity number 1 is as drawn below. Well, welcome to the solution of activity number 1. The triangle is again drawn there, and we are told that DE is parallel to BC. It is indicated in the diagram. We've also indicated the lengths of the different line segments. AD is 9 centimeters, DB is 3 centimeters, and BC is 8 centimeters as were provided in the question. Now, the proving goes as follows. Point number 1. From the diagram above, we can see that angle ADE is equal to angle ABC. Similarly, angle AED is equal to angle ACB. What is the reason? Because they are corresponding angles. Point number 2, angle DAB and angle BAC represents the same angle, and we call it common angle. So we have a reason of saying that DAE is equal to BAC. Then from the 2 steps above, triangle ADE is similar to triangle ABC simply by the reason pairs of corresponding sides are equal, angle-angle similarity theorem, or we could even say angle-angle-angle similarity theorem. Now, since the triangles are similar, it means corresponding sides are proportional. Thus, side DE is proportional to side BC. Side AB is proportional to side AD, and side AC is proportional to side AE. Therefore, we have a reason of saying that DE divided by BC should be equal to AD divided by AB. Reason, they are proportional sides. So the DE over, what is BC? BC is 8 centimeters. Therefore, DE over 8 centimeters is equal to 9 centimeters over 12 centimeters. 9 centimeters for AD and 12 centimeters for AB. How do you get 12? 12 is just 9 plus 3. Then from this simple equation here, by multiplying by 8 centimeters both sides, we end up getting DE equals 9 centimeters times 8 centimeters divided by 12 centimeters. And on simplification, we end up getting DE is equal to 6 centimeters. Solution for activity number 2. From the 2 triangles above, we are told that they are similar. ABC is similar to DEF. And you can see the information given in the triangles, whereby angle A is X in size, angle B 80 degrees, angle C Y in size, angle D 60 degrees, E, Z, and F, W. Now, we are told they are similar. If they are similar and we don't have any information about their sides, it means then the similarity is based on the angles. And for that matter then, angle A is supposed to be equal to angle D. A equal to D. Angle B is supposed to be equal to angle E. B equal to E. And angle C is supposed to be equal to angle F. C equal to F. Now, A equals D, but D is what? 60 degrees. But what is A? A is X. Therefore, I have a reason of saying that X is equal to 60 degrees by simple comparison. B equals E. But what is B? 80 degrees. So I have a reason of saying that B is equal to E is equal to 80 degrees. But what is E? E is Z. Therefore, Z is equal to 80 degrees. And finally, C, which is equal to F, meaning that W is equal to Y. But from triangle ABC, we can also say that angle X plus angle 80 plus angle Y is equal to 180 degrees. From the simple reason that sum of three angles in a triangle is add up to 180 degrees. But what is X? 60 degrees plus 80. Y? We don't know it. Is equal to 180 degrees. If we solve this simple equation, we end up getting Y is equal to 40 degrees. But from here, from this step here, Y is equal to W. Now, since Y is 40, equivalently, W should also be equal to 40. Henceforth, X is 60 degrees, Y 40 degrees, Z 80 degrees, and W 40 degrees. Once more, welcome to solution for activity number 3. We can see the figure for number 3 is there, and the question is saying, use the figure below to identify similar triangles. Now, this is the diagram given with the different dimensions. And then if you go straight to the solution, KO over NO is equal to 8 centimeters over 4 centimeters, which is equal to 2. LO over MO is equal to 10 centimeters over 5 centimeters, which is equal to 2. Also, if we observe the angles, angle KOL is equal to angle NOM because they are vertically opposite angles. And we know that vertically opposite angles are always equal in size. Then, from these facts here, triangle KOL should be similar to triangle NOM for the reasons that for the theorem side angle side similarity theorem. Look, we have ratio of these two sides, and the angle in between the given sides, the included angles, they are vertically opposite and they are equal. Therefore, these two triangles are similar by side angle side similarity theorem. Once more, welcome to solution for activity number 4. The question in activity number 4 says that use the figure to show that triangle EHI is similar to triangle EFG. The figure is this one here, whereby you can see you have two triangles with given dimensions, and what we have to agree is that EF is equal to 9 centimeters, EG is equal to 5 plus 10, which is equal to 15 centimeters. Now, in this question, we don't have any information about angles. However, we have all the sides given in terms of length. Therefore, quickly we can look at the ratios of sides. For example, if you look at ratio of side EH and EF, it is equal to 3 centimeters to 9 centimeters, which simplifies into 1/3. Ratio of side HI and FG is equal to 4 centimeters to 2 centimeters, which simplifies to 1/3 again. And ratio of side EI to EG is again equal to 5 to 15 centimeters respectively, which is also equal to 1/3. Now, from this fact that the scale factor is the same, 1/3, then we say that the corresponding sides are proportional. Now we can go back to our theorems earlier where we said that triangles can be similar if corresponding pairs of sides are proportional. Then we can conclude that triangle EHI is similar to triangle EFG, triangle EFG from the side similarity theorem.